Hey everyone, continuing with our finding intersection question types, we have the following example. So we have the graph of y equals to x squared plus x minus 2 over x plus 3, and I've already sketched the graph right here. By drawing a sketch of another suitable curve on the same diagram, deduce the number of roots of the equation 3x power 4 plus 3x cubed minus 6x squared minus x minus 3 equals to 0. So because it's quite guided, they tell you to sketch another graph and then deduce the root, which is likely an intersection type of question. So basically you have to find the equation of the second curve or second graph you need to sketch on the same diagram, and then deduce the number of roots, aka deduce the number of intersections between the two graphs that you have drawn. So it's actually quite simple, right? Your goal is to get back this particular equation on either side, so either on the left hand side or on the right hand side from this equation right here. So what I'm going to do is I'm going to draw this out. I'll write out the equation, and you notice that, okay, we want to get that particular equation, so let's bring x plus 3 to the other side first. So we have 3x4 plus 3x cubed minus 6x squared equals to x plus 3. Then we notice that I can factorize out x squared as well, so I'm gonna do that. I can factorize 3x squared because, we have 3 and 3, 3, 6, so they're all factors of 3, which I'll then get x squared plus x minus 2, which is just nice. Right, so we have the graph already, because what we can do next is very simple. We simply x squared plus x minus 2 divide by x plus 3 to give us the original equation. We then bring 3x squared to the right. Dividing that, we'll get 1 over 3x squared. As such, our second graph would be 1 over 3x squared, which has the asymptote at y equals to 0. Actually, I'm going to use another color for better visualization. But of course, if you're doing an exam, just use the same color. So y equals to 0. And we know how 1 over x squared graphs works, right? So it's always positive, so it'll never cross the x-axis. It'll remain on the top half. And as x approach infinity, as x equals 0, as x approaches infinity, we know that it'll tend towards 0. So we have a asymptote at y equals to 0 as well. So we have just this graph. So we have one root there, and then we'll have another root here, right? Because it's symmetrical, so this will be our y equals to 1 over 3x squared graph. How many roots are there? We have one intersection point here, one more intersection point here. The answer is 2 roots in the equation. All right, so this is the other type of intersection type of questions where you have to find the equation of the graph that is going to intersect with the original graph. All right, so there we have it, the second variation of our intersection questions.